So welcome back. So last time we talked about p-value test to analyze larger sample hypothesis testing. So this time we discuss using z-test to analyze larger sample hypothesis testing. Okay, the difference between p-value test and z-test is p-value test case. In this case, we set up the alpha value and then find p-value of each sampling distribution data. And then we compare alpha and then p-value. Sounds like we are comparing their percentage value and then make conclusion. But the z-test is we are not finding p-value of the sample. Instead, we are using their z-score. Therefore, in this z-test case, we need to find out corresponding z-score of alpha. So that's the big difference here. And then we will set up the reason of HO and HA based on this z-score, and then we analyze it. Okay, so look at these three graphs here. So as you see, the first one represent left tail test, second one right tail test, third one two tail test, right? And then you know why this is left tail and this is right tail and this is two tail. So briefly review, basically HA area represent types of a test. So as you see, HA pointing out the left side, so left tail test. Right side, right tail test. It doesn't have any direction, so we set up two different sides, so there will be two tail test basically. Okay, and then if you look carefully here, then here Z0, that's the basically corresponding z-score of alpha. And then we will find out this value using t-table this time. Okay, I know, so it's like why you may wonder why we're using t-table, why not z-table. Of course, we can find those z0 score based on z-table as well, but t-table is more useful, so that I'm gonna let you know how to utilize the z-score table. I mean t-table this time. Okay? Yes. Then let's continue to discuss this problem using example. In an advertisement, a pizza shop claims that mean delivery time is less than 30 minutes. Random sample selection of 36 delivery time has a sample mean of 28.5 minutes and a standard deviation of 3.5 minutes. Is there enough evidence to support the claim at alpha equal to 0.05? So, what is the first step we have to do it? Yes, set up the null and alternative hypothesis test. So, now, is it one tail or two tail? If you see any inequality phrase, then it will be one tail, maybe such as less than, more than, maybe at least, and most, something like this. Now, as you see, this one has less than 30 minutes. So it shows less than, right? Inequality phrase. So we know that this is the one tail. And the less than means going toward the left side, so it will be left tail test. So it becomes HA, mu is less than 30 minutes, and HO, U is bigger than or equal to 30 minutes, and this is their claim. Okay, now I'm gonna collect all the known data sets. So n equal to 36 because random selection 36 delivery times, and sample mean become 28.5, and standard deviation S equal to sigma equal to 3.5, and then given alpha equal to 0.05. Now, before we are finding z-score of sample, I'm gonna set up corresponding z-score of this alpha. Remember, this is the one tail. Okay? Now, we just go to t-table here. Then this is t-table. So, when you look at then t-table case, it shows that one tail alpha and two tail alpha. So we are talking about one tail test this times. Therefore, you are finding one tail alpha region here. Okay? So what was the alpha value? Yes, 0.05. Then you look at this column and then go to bottom here. So then it shows that infinite sign here, right? Which means it's a larger sample case. The number is, so let me double check. So 0.05, which is 1.645. Okay, one tail 0.05 become 1.645. There's two different one tail tests. One is left tail, second one right tail. So in this case, this sign will be different here. If it is left tail, then the z-score become negative. If right tail, then it become positive. Okay? So now, since it is the left tail test, I can set up normal curve here, and then that's corresponding alpha 0.05, z-score become negative 1.645. So it is clear to you why I put negative 1.645, right? Just once again, we using t-table and find the one tail alpha 0.05, and then we go down here, and there was the 1.645 here. If it is left tail, then negative. Right tail, then this is positive. That's the reason. Okay. Then now, your left tail, so this become HA, and this become HO here. Okay. Then, let's look for sample z-score. So, z equal to 28.5 minus 30 over 3.5 over square root 36. Then you will get about negative 2.5714 like that. So rounding 100 digit, then this become negative 2.57. Okay, now I'm gonna bring this number and here. And now, please analyze where this value is located. The centering on negative 1.645, does this value belongs to on the HA region or HO region? Yes, because negative 2.57 is smaller than negative 1.645, so this value belongs to on HA, right? Therefore, since the sample z-score belongs to HA, we can reject HO. So conclusion become reject HO. Okay? Then now, where was the claim? So claim was on HA. So claim was on A, and then we reject HO. So now we can conclude. So claim on HA and then reject HO. So there is enough evidence to support the claim. So the answer become there is enough evidence to support the claim. So that will be the answer for this question.